After several years of dominating the skies, the United States Air Force has, once again, shocked the world. Despite the underlying technological battle going on between world powers and the subtle threats of war, this country has focused on bolstering their military sector, and now the U.S. Air Force, with its fleet of advanced aircraft, just might be the most powerful in the world. What are the capabilities of this particular air fighter that has transformed this U.S. military? Is the USAF really the most advanced in the world? Join us as we explore the unique features of the U.S.'s ultra-modern aircraft that almost break the speed of light. This is not a story of the legendary F-22 Raptor or even the NGAD currently being developed. It's an aircraft with capabilities that has taken everyone by surprise. The journey began in the 1980s when the Pentagon started planning to upgrade its older fighter jets with new stealth planes. The Air Force's competition led to the F-22 Raptor, a powerful stealth fighter. However, the Navy and Marines needed their own stealth jets, and the Raptor was too expensive and specialized to replace the Air Force's many F-16s. In 1992, the Navy and Air Force merged their CAF and JAS programs to create the Joint Strike Fighter program. The aim was to develop a cheaper, single-engine stealth fighter that all three services could use to cut costs and that could also be sold to U.S. allies, unlike the F-22. The JSF would use the latest digital and material technologies for better performance. However, the need to design a single aircraft for all three services created problems. For instance, the Navy's version needed bigger wings and tougher landing gear for carrier use. The Marine Corps also required a jump jet that could take off and land vertically to replace its Harriers. However, VTOL capability makes a fighter bulkier, and jump jets like the Harrier and Yak-38 were much slower, carried less, and had shorter ranges compared to conventional fighters. The need for a single design for the JSF meant that even the non-VTOL versions would have a bulky fuselage that increased drag. The story of the mystery aircraft takes an unusual turn to Russia during the Yeltsin era. As the Soviet Union collapsed, the cash-strapped Yakovlev company looked for a partner to help develop its Yak-141 jump jet, which had a separate lift fan and could fly faster than the speed of sound. In 1991, Lockheed bought 3 Yak-141 jets and important test data from the Russian company for about $400 million. In 1996, the Pentagon gave Boeing and Lockheed $750 million each to build 2 prototypes, which were tested 5 years later. To summarize the result, Boeing's XO-35 had an awkward, bulky delta wing design and used tilted exhaust nozzles for vertical lift. On the other hand, the X-35 used lift fans similar to the Yak-141, but with a separate shaft, making it a more complex and advanced system. 5 years later, the Air Force chose the X-35, which led to the F-35 as the winner of the JSF competition. The Defense Department secured funding from countries like Australia, Canada, Israel, and others. These partners got their share of manufacturing and maintenance work, along with the chance to integrate their own missiles and other benefits. Designing the basic airframe was the easy part. The Pentagon planned to equip the F-35 with advanced technologies still in development. One innovation was using modular panels with built-in radar-absorbing material instead of applying it before each flight. Other new technology included a helmet display system for pilots to see through the plane, upgradable mission computers, advanced defensive systems linked to a multi-sensor system, stealthy data links for sharing data with friendly forces, and a radar with low detectability. The F-35 would also come with flight simulators instead of 2-seat trainers, and a logistics system for maintenance and spare parts. Usually it's smart to add new technologies to tested systems, but the Pentagon decided to develop the F-35 avionics, software, and airframe all at once, causing the basic F-35 design to keep changing. This led to delays and cost overruns as the new technologies didn't work together as smoothly as hoped. The F-35 ended up being 2,000 pounds overweight, which reduced its range, especially for the F-35B jump jet version. This led to a redesign that might have caused some structural issues in the early F-35B models. The Government Accountability Office raised concerns in 2006, and by 2009, the high cost drew attention from Defense Secretary Robert Gates, who considered canceling the program but found it too entrenched, having consumed too much money and effort. Gates even cut the planned production of the more advanced F-22 to just 180 aircraft instead of the 500, which was originally planned. As the F-35 fell behind schedule by about 5 years, the Pentagon had to spend extra money to extend the life of older jets. The testing department kept finding many problems, from faulty oxygen systems and misaligned cannons to unexpected computer shutdowns. Unfortunately, Canada also canceled its F-35 order due to these issues. The F-35 was only deemed initially operational for the Marine Corps in 2015 and for the Air Force in 2016, but with relaxed requirements. The Navy's F-35Cs were expected to achieve this status in 2019. The early production models of the F-35, which were supposed to be affordable, ended up being quite expensive, costing over $200 million each. These planes were missing key features and served mainly as test models to refine systems that would take many more years to complete. They will need costly upgrades before they can be fully operational. The expected cost savings from having 3 versions of the same plane didn't materialize as hoped, since only 20% of the parts are the same across all 3 variants. In 2013, the F-35 faced criticism for having limited range and being slower, less maneuverable, and carrying fewer weapons compared to earlier models. Supporters argue that these drawbacks are outweighed by the F-35's stealth capabilities and advanced sensors and missiles, which help pilots avoid close-range battles. The development and purchase of about 2,400 F-35s through 2037 are now expected to cost over $400 billion, which is about 8 times Russia's annual defense budget. Operating costs until 2070 are projected to add another $1.1 trillion. Despite ongoing issues with defects, delays, and low readiness rates, the F-35 program showed significant improvement in 2018. The price for each F-35A was reduced to $89 million, and Israeli and Marine F-35s saw their first combat. The F-35s performed well in air combat exercises. Belgium and Singapore recently chose to buy F-35s, and Greece, India, Poland, Romania, and Spain are also considering them. The F-35B jump jets will be used on Italian and British carriers and have even encouraged Japan to revive its carrier aviation program. What makes this aircraft special? Let's check out the specifics. The F-35 is designed to be stealthy, meaning it's hard for radars to detect. This is achieved by shaping the aircraft carefully and using materials that absorb radar signals. The airframe is designed with features like aligned edges, serrated skin panels, and engine masking to minimize its visibility on radar. The F-35 inlet design, called the diverterless supersonic inlet, further reduces radar visibility by eliminating certain features in traditional designs. The aircraft's radar cross-section, which measures its visibility to radar, is exceptionally low, even compared to a small metal golf ball in certain conditions. Lessons learned from previous stealth aircraft like the F-22 were applied to make the F-35 stealth design more durable and easier to maintain. The F-35 also minimizes its infrared and visual signatures and controls radio frequency emissions to avoid detection. The stealth design primarily targets high-frequency radar wavelengths, making it challenging for radars to spot the aircraft. The F-35 can use special Lundberg lens reflectors to reduce visibility further. There were concerns about the noise produced by the F-35, especially in areas near potential bases. Studies were conducted to assess the environmental impact of the noise. While the F-35 noise levels in decibels were similar to previous fighters like the F-16, its sound power, especially at lower frequencies, was stronger. Subsequent surveys indicated that for most people, the noise from the F-35 was not noticeably different from other fighters like the F-16 and F/A-18EAF. The F-35 cockpit, called the glass cockpit, is designed to give pilots a clear view of their surroundings. It features a large touchscreen display for flight instruments, weapons management, communication, navigation, and alerts, which pilots can customize. Below this, there is a smaller standby display, and the cockpit also includes a speech recognition system from Addisol. Instead of a traditional head-up display, this advanced aircraft uses a helmet-mounted display system that shows flight and combat information on the pilot's helmet visor. The cockpit has a single-piece canopy that opens at the front, and the ejection seat uses a twin catapult system to help the pilot escape in emergencies. It also uses a hands-on throttle and stick system, with a control stick on the right side and a throttle for aircraft control. It has an onboard oxygen generation system powered by the integrated power package, along with an auxiliary oxygen bottle and backup system for emergencies. The helmet-mounted display system, or HMDS, is key for pilot interaction. It replaces the traditional head-up display and projects crucial information directly onto the helmet visor, allowing pilots to see important details from any angle. The HMDS can also show infrared and night vision images, letting pilots see through the aircraft. Although there are concerns about its weight and safety during ejection, it provides a comprehensive view for the pilot. Speaking of defense, the F-35 can carry weapons on 6 external stations when stealth is not a priority. The wingtip pylons can hold AIM-9X or AIM-132 ASRA-AM missiles, and larger weapons like the AGM-158 JAS-SM can be mounted on inboard and middle wing stations. The F-35A has a 25mm GAU-22/A cannon with 182 rounds, while the F-35B and F-35C use a multi-mission pod for the GAU-22/A and 220 rounds. Lockheed Martin is working on a sidekick weapon rack to increase the internal air-to-air weapon capacity. Block 4 upgrades will allow the F-35B to carry 4 SDBs in the internal outboard stations and integrate the MBDA Meteor missile. For the F-35A, future upgrades may include close air support weapons like guided and fragmentation rockets, and possibly hypersonic missiles and directed energy weapons like lasers. Lockheed Martin is also exploring the use of fiber lasers for future enhancements. The F-35 mission systems act like its brains, helping the pilot understand and control the aircraft. These systems use advanced technology to work together, making the F-35 very effective in modern, network-based combat. Key systems include the Northrop Grumman AN/APG-81 radar, BAE systems and /ASQ-239 Barracuda electronic warfare system, Northrop Grumman's Raytheon AN/AAQ-37 electro-optical distributed aperture system, Lockheed Martin AN/AAQ-40 electro-optical targeting system, and Northrop Grumman AN/ASQ-242 communications, navigation, and identification suite. This 50th-generation aircraft was designed with future upgrades in mind. Plans include new radar and better sensors for future models. Lockheed Martin is also developing an advanced EOTS for improved performance. The F-35 is more than just an aircraft. It's a high-tech system that continues to evolve to stay ahead. To preserve its stealthy design, the F-35 has 2 hidden compartments inside, each with 2 slots for weapons. The outer slots can hold up to 2,500 pounds of weapons, or 1,500 pounds for the F-35B version. The inner slots are for air-to-air missiles. The outer compartments can carry various bombs and missiles for attacking ground targets, including smaller ones. The inner compartments are used for air-to-air combat missiles. When stealth isn't a concern, the F-35 can carry weapons on the outside. There are spots on the wing tips and in the middle of the wings for additional weapons, including air-to-air missiles or larger ground attack missiles. The F-35A has an internal gun, but the F-35B and F-35C versions don't have an internal gun. Instead, they use an external pod for the gun. Future upgrades include adding more small bombs to the hidden compartments and integrating new missiles like the MBDA Meteor. The F-35 might also be equipped with hypersonic missiles and directed energy weapons like lasers. The U.S. Air Force plans to use the F-35A for close air support missions to help ground troops in challenging situations. But being advanced and sophisticated are not the only features that make this aircraft very special. F-35A, for instance, can also be used as a tactical nuclear bomber. A few years ago, the Pentagon planned to upgrade the F-35A so it could carry nuclear bombs. This move was key for strengthening the Pentagon's deterrence strategy and giving commanders more tactical options. Recently, the Air Force showed that the F-35A can deliver a nuclear weapon into enemy territory, proving its effectiveness in this role. This successful test means the F-35A is now capable of handling tactical nuclear missions, enhancing its role in strategic defense. Its ability to handle both conventional and nuclear missions enhances the country's capacity to tackle various security threats. This makes the F-35A a crucial tool in modern military operations. While some other fighter jets can also carry nuclear bombs, this aircraft also stands out for its speed and accuracy. Unlike the stealthy B-2 Spirit and B-21 Raider bombers, which can carry bombs internally but fly slower, the F-35A can quickly deliver powerful bombs like the B-6112. The B-6112 is an upgraded version of older gravity bombs, with options ranging from 3 to 50 kilotons, which is more than double the size of the Fat Man bomb used in World War II. In 2021, two F-35As conducted a key test where they dropped B-6112 test bombs from 2,500 feet. These test bombs were designed to simulate real bombs without actual nuclear material. The test bombs hit their targets on the ground in about 42 seconds. This test, conducted at the Tonopah Test Range in Nevada, was a practice run for potential real-life scenarios. The purpose of this test was to check if the F-35A planes could carry and accurately drop a bomb similar to a nuclear one. By performing this test, they could see how well the aircraft would work in a real situation involving a nuclear bomb. This kind of testing is important to ensure the planes can perform as needed and keep the country and its allies safe. The U.S. plans to produce about 486 B-6112 bombs from fiscal year 2022 to 2025, while phasing out older, more powerful bombs. Experts estimate the U.S. currently has around 681 B-61 bombs, including 230 for non-strategic uses. That aside, the F-35 can carry a wide range of bombs, such as the Joint Direct Attack Munition, laser-guided bombs like the Paveway series, AGM-154 JSL, GBU-39 small-diameter bomb, GBU-53/B Stormbreaker, and even nuclear bombs. This variety of weapons showcases the F-35 capability to perform many roles in combat. For attacking ground targets, the F-35 carries powerful weapons such as the AGM-88G Advanced Anti-Radiation Guided Missile to hit enemy radar systems, and the AGM-158 JSSM for attacking ships. This wide range of weapons shows that the F-35 is a highly adaptable and advanced fighter, capable of handling various combat roles, from dogfights to strategic strikes. At the Airspace and Cyber 2024 conference, U.S. Air Force Secretary Frank Kendall suggested that the Next Generation Air Dominance or NGAD fighter might be redesigned to reduce its cost below that of the F-35. Originally, the NGAD was expected to cost hundreds of millions per aircraft, with plans to buy only 200 units. Kendall's comments follow his earlier statements in July 2024 about reevaluating the Air Force's approach to air superiority and potentially pausing the NGAD program. He also mentioned that decisions on NGAD need to be made soon for the fiscal 2026 budget. He emphasized that the Air Force is committed to maintaining air superiority and linked NGAD with the Next Generation Air Refueling System, or NGAS. Lowering NGAD's cost might involve reducing its range and payload, which would increase the need for tankers capable of operating in contested areas. Regarding the price, Kendall noted that no specific cost has been set, but mentioned that the F-35 price represents the upper limit they aim for. But that's not all. How would acquiring this fifth-generation fighter impact the Czech Air Force? While the F-35 meets all the requirements, there are some downsides to acquiring it. When choosing a new supersonic aircraft, several factors should be considered, including advancement and maintenance. One major advantage is that the F-35 is superior to other options. As a fifth-generation aircraft, it features advanced weapons and sensors for network warfare. This would bolster the Czech Air Force to the top tier of European NATO forces and improve cooperation with the U.S., NATO's leading member. Another benefit is the stronger alliance with the U.S. Acquiring the F-35 would deepen the partnership between the Czech Republic and the U.S. It would also boost the V4 group's capabilities, with Poland buying 32 F-35s and Slovakia 14 F-16Vs. If the Czech Republic acquires around 20 F-35, it would significantly enhance air power in the region. If the Czech Republic chooses the F-35, the aircraft will come with the latest upgrades known as Block 4. This will include new weapon systems and improved software. Besides adding U.S. weapons, it will also integrate European missiles like the Norwegian Joint Strike Missile, MBDA Meteor, ASRAAM, and Spear missiles, With more European weapons available, the F-35 arsenal will expand, making it comparable to the JAS-39 Gripen in terms of weapon variety. As mentioned earlier, the biggest downside is the cost. The aircraft itself is expensive, but the operating costs are even higher, which raises concerns about whether the Czech military can afford it, given its other expenses. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.